Okay, the next step here is talking about biconditional statements. For a biconditional statement, our main focus is on our original conditional and our converse. Remember, if my conditional is P then Q, my converse is when I switch those, Q then P. Those are the two things I'm focused on here. In this statement it says two lines that are perpendicular intersect to form right angles. So my conditional would be if two lines are perpendicular, then they form right angles. In my converse, I have to flip those. But again, I can't say if they form right angles because I haven't defined what they are. So I do want to say if two lines form right angles, then they, I can use they in my conclusion, are perpendicular. Now let's talk again about our truth values. Are they both true? Well, I'm not sure how much background you have on perpendicular lines and right angles, but the fact that they are perpendicular means that they are right angles. I cannot come up with any example or counterexample to that. If lines are perpendicular, where they intersect, they form right angles. So that is a true conditional. Now, if the lines form right angles, so we know they're intersecting and they're forming right angles, well, what do we call that? We call that perpendicular. That's also a true statement. So, since I have answered this question, yes, the conditional and converse are both true. I have no counterexample to either one. We have what we call a biconditional statement. And we use the phrase if and only if. Essentially, we have a definition. A definition would have to have both of these ideas. Okay? So we can rewrite this into what we call a biconditional statement using the words if and only if. Example: if you are at least 16 years old, then you can get a driver's license. That's a true statement. If you're at least 16, then you can get a driver's license. The converse, if you get a driver's license, or if you can get a driver's license, then you are at least 16 years old. That is also true. Since they are both true, we can combine our two ideas into what we call a biconditional statement. It wouldn't use if-then. It's going to use if and only if, and the if and only if will come in between my two statements. So I might say something like, you are at least 16 years old if and only if you can get a driver's license. Or, you can get a driver's license if and only if you are at least 16 years old. So let's try it that way. You can get a driver's license if and only if you are at least 16 years old. So, let's get a few more practice problems here. Each of these following statements is true. So every conditional statement I've given you down here, you can assume is already automatically true. we're going to write the converse of our conditional, determine if that's true or false. If it's true, we have a biconditional statement. If it's false, then we should be able to provide a counter example. So let's go ahead and take a look at our first one. If two planes intersect, then they contain the same line. That's true. The converse, if two planes contain the same line, then, I didn't give us enough room to write this, but I'll write it above, they intersect. We didn't spend a ton of time talking about planes, but two planes, when they intersect at a line. So that means this statement is also true. There's no way that they could intersect and not form a line. So, since it is a true statement, my converse is true, I have a biconditional. I would state it like this. Two planes intersect if and only if they contain the same line. Period. Okay, let's look at the next example together. I'm telling you that if a number ends in 0, then the number is divisible by 5. That's a true statement. Every number that ends in 0 is divisible by 5. My converse would be if a number is divisible by 5, then it ends in 0. Is that statement true or false? And remember, if it's true, we'll write a biconditional. If it's false, we have to have a counterexample. Well, can we come up with a number that's divisible by 5 that does not end in 0? Sure. The number 15. 15 is divisible by 5, but it ends in 5. So my converse is false. I have to come up with my counterexample, which we did as 15. I can't write a biconditional here. It's not an if and only if statement. So, the next two problems here are ones I want you to try. Do the same thing. Determine if your converse is true or false. True, write the biconditional. False, write the counterexample. Go ahead and press pause and try both of them. When you're done with them both, unpause to check your work. Okay, so right now all I've done is written our converse. But in this case, both of these are going to be false. I can come up with plenty of numbers that are odd that are not prime. One example might be 21. 21's an odd number, but it's not prime because it's divisible by 3 and 7. So that's my counter example. And in the last one, I can come up with plenty of numbers that makes you a teenager that's not 15. 16, a 16-year-old is a teenager, but they're not 15. So that would be my false converse statement and a counterexample. So to summarize, if your conditional and converse are both true, you have a biconditional and can write your statement in if and only if form. However, if one of those two statements is false, then it is not a biconditional, and you would need to come up with a counterexample to the false statement. The last set of videos that we'll talk about next are going to be talking about our laws of logic and how we can follow different truth values from multiple conditional statements to get to a final conclusion.